Hello and welcome to my video, lesson 2.3b, the other half of Sine Law, which is the ambiguous case. So the ambiguous case is a challenge because, well, it's ambiguous. We don't know the answer, and so we have to give multiple options. So Sine Law is given here. This is the gist of Sine Law, and if you don't remember that, please take a look at the last video where I talk about Sine Law in 2.3. Basically we've got these ratios here, and we're able to find the fourth side, the fourth value out of 4 if we have the other 3. So if we have 2 angles and 1 side, we can find another side. If we have 2 sides and 1 angle, we can find another angle. And that's basically the rule. Now, normally it just kind of works, but in certain cases, it is ambiguous, which means we don't actually know the right answer. So what we need to do is add cast rule on top of the regular sine law. So let's take a look here and see why that happens and see a case where that happens. If you feel ready, you can definitely pause the video here, try it out for yourself, and see if you get the same answer that I do. Alright, so basically, we have this triangle here, and these are the 2 sides given to us, and we're looking for this angle on the left, and we're given the angle on the right. Now, the part about this that is ambiguous is if the drawing is not given to us, there are actually 2 possible answers. And so I've gone ahead and drawn both. So if I put this on top, you'll see, again, in the same positions, right? It's the exact same positions as before. We've got the 20 degrees on the top right, we've got the unknown on the top left, and then the top side is not known, but the bottom right is known, and the left-hand side is known as well. So if you look at that, it kind of overlaps, and basically what's happening is that this arm, you could say, oh, whoops, I didn't mean to change that whole thing. This arm here just swings inwards, so it's the same length as before. It stays 10 degrees, but it could be that theta is now a big value. So either theta is an acute number or theta is an obtuse number, which fits with cast rule, because in cast rule, where is sine positive? Well, it's actually positive in 2 places, where it is acute and where it is obtuse. So maybe you can notice that. So that is basically what's going on here. We've got, I want to get rid of that, but there you go. Basically, that's what's going on here. So now let's go ahead and try this out. So from our calculator, if we just plug it into these formulas here, what we're going to get is sine theta over 15 equals sine 20 over 10, because those are the different related sides. We'll move the 15 over, so we'll have sine theta equals 15 sine 20 over 10, which we can then change to theta equals sine -1 of 15 sine 20 over 10. Now, if we plug this into our calculator, what are we going to get? So I'm just going to bring the calculator over here. Second function, negative sine, we're going to put it in a fraction form, 15 sine 20 over 10 in brackets, and we get 30.86588, whatever. So I'll call it 30.866. So you'll notice here that this is our angle, but it's only the obtuse version. I mean the acute version, sorry. So that is actually not the angle, it is the reference angle. And so it does work for one of the two angles because the reference and the standard angle are the same in quadrant 1. However, how are we going to get this obtuse angle? Well, we're going to do the same thing as if we had the reference angle up here, and that reference angle was that 30.866. So what are we going to do? Well, we're going to go 180 minus 30.866, and that is going to be our angle. So 180 minus 30.866, whatever. So 1.4913. So 14913 degrees. I believe that's correct. Let's just double check. Yes, indeed, that is right. Okay, so this is an example of how the cast rule can apply to sine law. Now, be careful that you're actually drawing these correctly. Cast rule does not always apply to sine law. If you have the drawing given to you, that might already indicate that it would be one answer over the other. And in some cases, if you got a bigger value, then all the angles in the triangle would add up to a value bigger than 180, and obviously that does not work either. So you have to have all the angles add up to 180, and in these cases it will. Speaking of angles that need to add up to 180, here's another triangle for you guys to try out. At this point, since I've done one, I do highly recommend that you pause the video, try out for yourself, and see if you can get the right answer. Alright, so here's the question. Airplane towers don't always exist at the airport that they control. At some smaller airports, one control tower will control multiple runways across a large area. So, for example, my understanding is that Edmonton is actually kind of like a hub where we control runways in northern Alberta. Not all of northern Alberta, but the smaller runways up there. So if that's wrong, then sue me, but that's my understanding. Okay, so it is determined that a plane is 75 kilometers from a tower, is 35 kilometers from the runway. If the tower reports that the plane is spotted 5 degrees above the horizon, how far away is the runway from the tower? So this is the drawing for you, but this would not actually be given in the question. This is just, it takes a long time to draw it on the computer especially, so I wanted to draw it ahead of time. But you should get to this point here. That would be the main step, and on the one hand, I already did it for you. So yeah, hopefully you got it. The next step is to recognize what we're actually looking for. We're looking for the distance between the runway and the tower. So left to right here. So where I wrote the X, that's what we're looking for. Now, in regular sine law, what we need to do is we need to go X over sine, and then the angle that's opposing. So that's this angle here. Now, that angle there is actually unknown. So right now, we're actually stuck there. We can't do anything further. And so this is where we're going to have to get even more creative, because we need to get rid of this theta here in order to find the X. How do we get rid of the theta? How do we put a number in there? Well, we need to figure out theta some other way. So what if we find instead this angle in here first, and then to find that angle, it could be okay, to find that angle, what we can do is go 180 minus theta minus 5 equals that angle up there, because all the angles must add up to 180. Okay, so that's what we're going to do. Now, this is one option, right? But keeping in mind that this part, this arm, could also swing this way, right? And so if it swings this way, now we're going to have a much smaller angle for theta up top, and therefore much smaller x value as well. So keep that in mind. Let's focus on the first version first. So in green, we have, we're looking for that angle, so that is sine theta over 75 equals sine 5 over 35. Again, because those are related sides, and these are related sides, so that's why we're using that. So anyways, solving this just like we did before, I'll go step by step. 75 sine 5 over 35. Theta is equal to sine negative 1 of 75 sine 5 over 35. All right, now you have to remember here that what we're finding is we're finding the reference angle. So just keep that in mind while I'm finding this. This is 10.76, and this is the reference angle, 10.76. Now, in the original, that's actually what that is, okay? But due to cast rule, it could also be that we're looking for this angle, or because of the ambiguous case, this is the angle we're looking for, which is obtuse, which is actually 180 minus 10.76, which is 169.24 degrees. Okay, so you can see that there are wildly different options. 169, I'll just leave it there, 169 degrees. So those are two wildly different options, which are also wildly going to change the red answer, right? So if we did it in green, what we would get is 164.24 degrees. If we were to get it in blue, we'd go 180 minus blue theta minus 5, which would be 4.24 degrees. Is that correct? No, that's not quite right. Sorry, 5.76 degrees. That should be right. Okay, so you can see how those are wildly different. Those are the angles up here. So either this one here is 5.76 degrees, or this one is 164.24 degrees. I'll just leave it 164. Okay, so those are two wildly different degrees here. All right, so depending on the circumstance that we're looking at, we're going to place two different values in here. But let's just leave it as, I'll call it Y for now, no, Z for now, which is going to come from these values here. Okay, so in the first option, it would be x equals 35 sine Z over sine 5. Okay, so now what we can do is just plug in both of those different values. So 35 times sine of 164.24 over sine of 5. So 109. I'll leave it 0.1. And then the other option would be very similar, but it would be 5 5.76, and that would be 40 point, what did I say, 0.3, and that's not degrees, these are kilometers. So my bad there, those are kilometers. Okay, so basically we're talking about the difference between this full thing would be 109.1 kilometers compared to this one. I'll just do it a little bit bigger. Compared to this one, which would only be 40.3 kilometers. So that makes a big difference. Alright, so hopefully this video helped you better understand ambiguous case and how much of a difference that would make and why it shows up with the arm swinging across, as well as how to use CAS rule to solve them and get around the issues of ambiguous case. Hopefully this video helped, and good luck!